All right, what's up, everybody? It's Hutch here, and this is Module 1, Lesson 4. So here's your I can statement. We're looking at graphs of proportional relationships today. It says that I can determine if a relationship is proportional by analyzing its graph. And we really want you to be able to explain what points 0, 0 mean and coordinate points 1, whatever the y-axis is. They're calling it r. What those mean on the graph of a proportional relationship. So let's go ahead and take a look at things. The first thing I want you to see is a very straightforward concept that you want to drill into your head and remember, and that is when you look at a graph, it's really easy to tell if it's proportional or not, because two things has to happen. Okay, number one is it has to be a straight line through the origin. So let's highlight this. Straight line through the origin. And what that means is when you look at these two graphs, in order for it to be a proportional graph or a proportional graph of data, you have to see a straight line. So we see that with both. But the other characteristic that has to be true is that line has to go through 0, 0 here. Okay, and so you can see one of them does and one of them doesn't. The one that does means that it is proportional. So let's go ahead and write that. The one that doesn't go through 0, 0 here means it is non-proportional. Okay, because it has to be straight and it has to go through 0, 0. Okay, all right, so let's go ahead and take a look at example 1. Okay, so we have a rabbit challenges a tortoise to a race. The table shows the distance that the tortoise moved after 0, 1, 2, and 3 minutes. So we want to see if the data of distance traveled per minute is proportional. So let's go ahead and step 1 is to graph the relationship. So one thing you have to remember is look at your labels on your axes. And this is your x-axis and this is your y-axis. So just don't forget about that. They do show it right here as well. Okay, and we always, when we're graphing, are looking at ordered pairs. Remember, an ordered pair is like this. This is the x and this is the y. So I just want you to, just a quick review on that. So time is the x. So sometimes what I'll do is I'll label them up here so I can see what's what. Okay, so our first point is at 0, 0. Our next one is at 1 minute. So over 1 and up 6. Over 2 and up 12. Over 3 for time. And then up 18. And there we are there. Okay, so there's our line, and we can go ahead and draw that line down and hold it to connect the dots. And so there's our graph. And so did it follow the two things to be proportional? Is it straight and is it intersecting with ordered pairs 0, 0? And since the answer is yes, describe the relationship, and we can say it is proportional. Okay, relationship between time and distance. Okay, all right. The next example, example 2, the rabbit challenges the tortoise to a race. Okay, let's determine if the relationships are proportional. So let's start by graphing it. Notice they're giving you distance here, which means this is time. So I'm going to go ahead and label that time in minutes. Okay, and this is my x-axis and this is my y. Okay, so go over here, and again, I like to label it on the table so I can see. So at 0 minutes, we have 0 distance. So far, it's meeting our characteristics for proportionality. At 1 minute, we went 8 feet. At 2 minutes, we also went 8 feet. So right here, you can see our line is not proportional anymore, or this data, because it's not a straight line. And then at 3 feet, we went 15, which is right there. Okay, and so my line goes like this, and that is not a proportional relationship, okay? Because if I were to divide 8 divided by 1 and then 8 divided by 2, we would not get the same unit rate. So we know the relationship is non-proportional, okay? All right, so both characteristics have to be true. All right, so let's go ahead and look at something else. One of your objectives is to be able to look at the graph and determine if the graph is proportional, but also to understand what 0, 0 is, and also understand how to see the constant of proportionality or the unit rates within the graph. So one of the things I want you to look at is, first of all, understand that when you're at ordered pair 0, 0, that means that at 0 seconds, there's 0 of the other thing happening too, which is the distance, okay? So that's what 0, 0 means. The next thing is that we can find the unit rate or the constant of proportionality with any of the points that intersect, okay? And so to find that, okay, all we have to do is look at y over x, okay? And that is the division that we're doing to determine the constant of proportionality, okay? And we want to specifically, though, if we can find where x is 1, the y is actually going to be our COP, our constant of proportionality. So this is a big one to sort of highlight. If you can see where x is 1, it'll tell you the constant of proportionality when you see a straight line going through 0, 0. So let's check that out and see what I mean. Okay, so if I look at this spot right here, okay, we can see, well, x is 1 and y is 5. And so when we have a unit rate of 5 over 1, so this is 1 second, is 5 meters. Well, here's my constant of proportionality. Okay, we know how that works, right? And then we can look in other points in the graph too. And even though they're different, we know how to find unit rates. So for example, if you look at something like this point here, they said, well, the x for this one is 4. So they did y over x. And the y is 20. The x is 4. Well, we know how to find unit rates, right? So 20 divided by 4 is also 5 over 1, and there's our COP. So you can do that with any ordered pair. You just have to know what is the x and what is the y, and then set it up like that. Okay, so let's go ahead and try that out a little bit. Here's example 3. So here's a 100-meter race, and it says assuming the runner's rate is constant, okay, that he's not going to tire out, the distance run is proportional to the time spent running. So here's the data shown, okay, and let's go ahead and take a look at finding the constant of proportionality. So step 1 would be to look and see, is this a proportional graph? So yes, it goes through the origin 0, 0, and it's a straight line. So we're good with that. Let's calculate the constant of proportionality. So step 1 would be to look, do you see where x is 1? Because we know that just tells us the constant of proportionality. And the problem with this one is it doesn't quite fit on an intersection, so we can't clearly see what it is. And so when that happens, we're going to have to look at some intersecting points that exist. Okay, so the best one that I can see that really intersects well is it looks like this one right here. Okay, and so let's go ahead and check out what this would be. So this is identify the ordered pair. This one is ordered pair 5, 30. And remember, this is x and this is y. So let's go ahead and set it up in that format of y divided by x. So I have 30 divided by 5, okay? And what is that as a unit rate? Well, 30 divided by 5 is 6, okay? And so we know that this is my COP, my constant of proportionality, okay? We've done that in our last lesson, okay? And so we found the constant of proportionality, and now we need to describe what it means. I'm hesitant. They're showing these other points, but the points that they're showing aren't really on a good intersection. Maybe this 10 and 60 right here is pretty good. So we could do this point, which would be 10 and 60. Okay, and remember this is x and y. And so y divided by x would be 60 divided by 10. What's the unit rate? And it's the same. Okay, and so we verified there's a COP. I don't really like any of the other intersections that I see there, so I wouldn't even do a third one. I think 2 is enough for that. That other point is not one that you'd want to do because you'd sort of be guessing what the distance is. Okay, so it does say describe what it means, and I do want you to be able to understand this verbally. Okay, and so this means for every 1 second, comma, what do you think the distance is? So for every 1 second, let's see, is it running? The runner goes 6, and let's look at the units, meters. Okay, so I understand for every 0 amount of seconds, we go 0 meters. For every 1 second, okay, the runner goes 6 meters. So there's my information that I need to be able to interpret. So let's go ahead and analyze some more points like that on these graphs. The key points to remember is a graph is proportional when the line does what? Passes through 0, 0, which is also called the origin. Okay, sorry, it's a little sloppy there. And is what shape? Straight. So those are 2 characteristics that we need to keep an eye on. All right, so let's go ahead and analyze these points. Okay, so example number 4 says we're looking at the number of teachers compared to the number of students. Okay, and so if this is proportional, okay, then it goes through ordered pairs 0, 0, which we see, and it's a straight line. So we know we have a proportional relationship. Let's go ahead and interpret this. So it says right here, the 0.00 means that for 0 teachers, there are how many students? Yep, that's right, 0 students. So just understanding that relationship is important. What does the 0.125 mean? Okay, so this is the x, remember this is the y. So for every 1 teacher, what does that mean? There are 25 students. Okay, so this also means that the constant of proportionality is 25. That's the COP. The unit rate is 25 students for every 1 teacher. So that's our multiplier that exists too. Okay, because remember we could take this, x and y, and what's that formula? Y over x, or 100 divided by 4, and that's going to equal 25 per 1. So 25 students per 1 teacher. So we can see it equals the same unit rate. Okay. All right, let's go ahead and do your apply here, and that'll be it for these notes. So Michelle and Angelo are participating in a school fundraiser. The number of items each student sells after 1, 2, and 3 days is shown in the table. Which ordered pair represents a unit rate for the number of items sold per day? So we want to find the relationship that is proportional. And so here's what you need to notice, though. They're saying how much they sell per day. Okay, so we have to look at these separate. Okay, and so really what we have is this is 1, and then the days with Angelo is the other. Okay, so let's sort of think through this a little bit. If this is my x and this is my y, okay, this is actually my other y. We have two separate things going on, okay? So we could graph it, but that's a little bit tricky to do, okay? Or we can just use our understanding that to test for proportionality or to find a constant of proportionality, we can use the formula y divided by x. So let's go ahead and just test some of these out, okay, and find the unit rates. We can do the 3/1, okay, y divided by x. That's already in a unit rate, okay, and then let's just test out one more. So let's do the 6 and the 2, okay, so plug that in. 6 would be the y, and 2 would be the x. So 6 divided by 2, what's the unit rate? Okay, so 6 divided by 2 is 3/1. So we have a constant of proportionality, which is 3. So Michelle's numbers are proportional. Okay, it's for every day she sells 3 items. That's our constant of proportionality right there. So now let's go ahead and test Angelo. Okay, so I'm going to get rid of my y here because my new y is looking at Angelo's information. So let's do the same thing, y over x, and we're going to test out and do that division. Okay, so number of items per day. Okay, so let's go ahead and see. We have, you can't use the zeros to test anything. You have to use other things. Okay, so let's see. One number of items per one day. Okay, there's the unit rate. So it's a 1-to-1 ratio. So if you look, are the other ones 1-to-1 ratios also? Okay, her other one, if we do y over x, let's go ahead and test. We might as well test this one out here. Okay, so that would be 5/3. Pretty sure this isn't going to work out. Okay, so what's the unit rate? 5 divided by 3. 5 divided by 3. I already know this isn't going to work. 1.6 repeating items per day. So we can see Angelo's information is not proportional. Okay, so which ordered pair represents a unit rate for the number of items sold per day? The Michelle's number of items represents a unit rate for number of items sold per day. Okay, and so we have the 3 items sold per day. Okay, so there is your apply for that, and you're all set to head to your homework. Remember, your homework is going to align with each of these examples, so go ahead and put them side by side if you need some extra support with that.